me, Sheikh. My name is I am pursuing Bachelor's of Technology in Electronics and Communication Engineering in University College of Engineering, Nasrafet. I have completed 1 month online internship in Emertxe technologies based on Internet of Things. I have completed a project that is home automation based on Internet of Things. So the contents are topic learned during internship, what is IoT, IoT architecture, what is embedded system, project requirements. Project requirements such as a software and hardware, screenshots of software, conclusion, implementation of the project. So topics covered during internship are our mentors had a brief introduction of C programming and C++, and also they had discussed about the basics such as keywords, basic data types such as integer, character, float, double, void, operators, conditional constructs and looping concepts, arrays, pointer functions, built-in and user-defined functions, storage classes, preprocessor directives, and header files. And also we had learned about C++ programming based on OOPS concept, and also about introduction of IoT, definition of IoT, how the architecture of IoT is there, and introduction to embedded systems, definition and the types of embedded systems, components of embedded systems, peripherals such as LED, LDR, etc., Arduino Uno board, CLCD, that is a 14-pin description of CLCD ADC, and the use of ADC in Arduino. And peripherals required for the project. LDR sensor to read the sensor values, and based on the reading it varies the brightness of LED, such as if the brightness is very high, such as the light intensity is very high, then the LED is off. If the brightness is higher, LED is off. If the brightness is lower, that is the intensity is very low, then the LED starts glowing, that is said to be on. Coming to the second one, temperature system. It consisting of heater, cooler, LM35 temperature sensor. We can read the temperature from the temperature sensor. Next one is nothing but serial tank. We can read the volume of the water tank through the serial communication. Next, coming to introduction to IoT. The Internet of Things is the network of physical objects that contains embedded technology to communicate and sense or interact with their internal states or the external environment. These devices range from ordinary household objects to sophisticated industrial tools. With more than 7 billion connected IoT devices today, experts are expecting this number to grow to 10 billion by 2020 and 22 billion by 2025. By means of low-cost computing, the cloud, big data, analytics, and mobile technologies, physical things can share and collect data with minimal human intervention. In this hyper-connected world, digital systems can record, monitor, and adjust each interaction between connected things. The physical world meets the digital world and they cooperate. Coming to IoT architecture. In IoT architecture, we do have a big data warehouse, such as where the data is stored. And also we do have a sensor data, such as a control applications. We do have modules based on machine learning, data analytics, user business logic, web applications, mobile applications, and coming to administration services, we do have device administration, user administration, security monitoring, streaming, data processor. And we do have cloud gateway for the backup of a data and control data. Next, sensor data. We do have gateway through and such as sensors, actuators, smart devices, sensors, etc. This is the IoT architecture, where we do find machine learning modules and also the big data warehouse where the data is stored, and where the cloud gateway From that we can retrieve the data, that is there will be a backup plan also. And streaming data processor, it acts as a database of a particular information. Next, coming to embedded systems, any combination of hardware and software which is intended to do a specific task can be called as embedded system. It has three parts. We can consider them as software, firmware, and the hardware. Unlike computers, embedded systems perform few specific limited tasks. Embedded devices have peripherals such as serial communication interference, where the communication is in only serial, not but parallel, and also synchronous serial communication interference, universal serial bus, multimedia cards such as SD cards and compact flash, etc. In embedded system, this is a architecture of embedded system. In a microprocessor, we do consider CPU as a heart, right? In embedded system also, we do consider the CPU is the heart of the embedded system. Unlike CPU is a bidirectionally connected and interlinked to the many peripherals such as software, FPGA, ASCII, and also A to D conversion, that is nothing but analog to digital conversion, user interference, diagnostic port, next digital to analog conversion, memory. So memory space, actuators, electromechanical backup and safety. We do have sensors and external environment here, right? This is about the architecture of embedded system. So coming to the project requirements, first one is nothing but control garden lights based on sunlight. Lesser the sunlight, brighter the garden lights. That is nothing but it is based on the photo intensity. That is nothing but light intensity. Based on the light intensity, the sensor senses the light intensity and also provide the output such as LEDs. If LED is on, then the photo intensity of light intensity is very high, low. For example, let us consider it's a daytime. So the sunlight is more, that is nothing but light intensity is very brighter, so the LED will be off state, right? So at night time the light intensity is very lesser, so the LED glows up, then the LED is said to be on state. Next, coming to temperature system control, switching the heater and the cooler on or off remotely. Switch heater off automatically if the temperature rises above 35 degrees centigrade. Next, coming to water tank control. Switch inlet and outlet valve on or off remotely. Switch inlet valve off automatically if the tank fills up. Switch inlet valve on automatically if the volume of tank drops below 2000 liters. Next, coming to the requirements for the project are, we do require both hardware and software. Coming to hardware, we do use Arduino Uno, Ethernet W5500, PCF 8574, temperature sensor, LCD HD 44780, LDR sensor, LED. Coming to the software requirements, we do require Arduino IDE to write our code, PixSimLab for simulation process, and also to have a spare parts required for the project, null modem emulator to configure ports of serial remote tank, Blink IoT app, cloud server. First one is nothing but Arduino Uno. Arduino Uno is based on Atmega 328P microcontroller. It is easy to use compared to other boards. So we can be use this very easily. Like means we can understand its architecture very easy compared to other boards, and also their pins such as Arduino Mega board, etc. The board consisting of both digital and analog input-output pins, shields, and other circuits. Arduino Uno includes 6 analog inputs, 14 digital pins, a USB connector, a power jack, and ICSP is nothing but the in-circuit serial programming header. It is programmed based on IDE, which stands for Integrated Development Environment. It can run on both online and on the offline platforms. So this is a Arduino Uno board, right? This is a Arduino Uno board, and on the right hand side we do observe the pin description of a Arduino Uno. Here at lower we do have analog pins right here, and here we do have 5-volt supply and 2 ground pins, 5-volt supply and 3.3 volts. Here we do have reset and input output reference pins. So this is a USB connector, and also here we do have transmitter and receiver LEDs. So whenever the LEDs are glowing, whenever we upload our code to this, if the LED glows, then we can come to notice that the board is working. Otherwise the board isn't working. So here we do have a transmitter and receiver pins known as from here 0 to 13. These are the digital pins, right? And also we do have data and a clock. This is about the pin description of Arduino Uno. And Ethernet W5500 is a hardwired TCP IP embedded Ethernet controller that provides easier internet connection to embedded system. W5500 enables user to have internet connectivity in their applications just by using the simple chip, that is nothing but single chip, in which TCP IP stack, 100 by 100 Ethernet MAC, and embedded systems. Supports power down mode, supports wake on LAN over UDP, supports high speed serial peripheral interface, and this is a screenshot of Pixim Lab spare parts. So we do have here files, edit, and also a number of inputs we do require, and the output such as LED, and the input such as the temperature sensor, etc., and others virtual and also help. So in others we do have a spare parts, right? So these are the spare parts required for our project. Coming to temperature sensor. A temperature sensor is an electronic device that measures the temperature of its environment and converts the input data into electronic data to record, monitor, or signal temperature changes. For example, so whenever the temperature whenever the sensor is at room temperature, then it will be normal. If there is a difference in temperature, then the output is based on that. So for example, if we write a code such as if the temperature increases, then the bell rings. If the temperature decreases, then the LED glows, emergency LED glows. So this would be the some of the programming ideas. And coming to LM35, it is a temperature sensor. So it is having a 3 pins. First one is nothing but supply one, and second one is nothing but output, and third is nothing but ground. This is a side view of LM35, and this is a front view, and these are the pins. We read from left to right. Next, LCD HD 44780. So liquid crystal display. We do say LCD as a liquid crystal display. HD 44780 is a dot matrix liquid crystal display controller, and driver LSI displays alphanumeric and symbols. The major function of a LCD is nothing but to display alphanumeric and symbols and many more. And there are different types of LCD. Here we use 16 by 2 LCD in the project. It can print 16 characters in a row. It can configure it to drive a dot matrix liquid crystal display under the control of 4 or 8-bit microprocessor. So this is a LCD, right? And next, so this is a picture which we do see in a Pixim lab, right? 16 by 2 CLCD display in Pixim lab, right? It can be obtained in a spare parts, right? And also LDR sensor. The LDR is a component that has a resistance that changes with a light intensity that falls upon. This allows them use to in light sensing circuits. The resistance of photoresistor decreases with increasing incident light intensity. In other words, it exhibits photoconductivity. This is a side view of a LDR sensor. So this is a front view, right? This is nothing but sensible sensitivity adjustment. So we can adjust this, and from left we have to read the pins from left to right. So it is a VCC. Second pin is for ground, third is for digital output, and fourth is for analog output. Firstly, after the completion of writing code, we will save that, and also we need to create a hex file. So whenever we create a hex file, then this will be available for us, otherwise it will not available for us. Next, LDR is high, so LED is on. So whenever the LDR is high, then the LED will be on. If LDR is low, so LED is off. This means that the light intensity is very much lower. That's why the LED is off. Otherwise the LED is on. Cooler is on. So here the display shows that by operating remotely, we on cooler and we off cooler. Heater is on. So here the based on this temperature, it is 31.77. So the heater is on. The heater is off whenever it reaches above 35 degrees centigrade. Inlet valve is on. So inlet valve is on is nothing but the volume of a tank rises above the 2000, such as, so it rises above 2000 and the water flows through the tank. If inlet valve is off, that means that the water flow will be stopped, and also the flow of water is, so here the flow of water will be stopping. So outlet valve is on is nothing but the tank stops the water flow, right? So it will be above, volume will be about 2000. So whenever the outlet valve is off, the water flows through the tank and the volume will be less than 2000. And we notification for heater temperature. So we will remotely on and off a cooler or a heater in Blink IoT app. So heater will automatically turn off when the temperature rises above 35 degrees centigrade. Here the temperature is 35 degrees centigrade. So the heater turn off. Otherwise it will be on. Notification of water level. So if the water tank is full, inlet valve will automatically turn off and it shows the volume of 3000. Otherwise it shows 19,000 or 2,000 like that. So this is the code we have written here. This is a serial tank, code for serial tank. We have written everything right, like including heater, about heater temperature and everything, and the templates, right? And also we will be saving this, compiling the sketch, and we do convert this into hex file by export compile one. So no errors are there, it's correct. Next we'll go for Pixim lab, and also we do see this spare parts, right? This is a Pixim lab, and we use Arduino Uno board, and by clicking others we do see tools here like serial remote tank. So here the bulb is glowing, right? So the first LED is glowing, right? So based on that, serial remote tank. So based on the temperature, the LED glows there. This is about home automation, and we'll change the properties of LED. So we'll consider as third pin 1 is for LED, which is connected to third one in our Arduino. And also this is a tank, serial remote tank. We'll convert it for 3, or we can, it's our wish for, we can be taking C com 3 or com 2, no problem. And we'll be loading hex file, clicking home automation, opening the home automation file. And also I had placed the Arduino folder. We do use home automation, and double clicking that and opening, we'll be open that file. So we'll be seeing that display home automation, and by decreasing the brightness, there will be change in LED glow, right? So the temperature also varies and the volume also varies. So based on the brightness, it varies. And also here the bulb is also varying. We can change the properties. So we'll be changing the properties. So based on the properties also, our project will be based on how the properties are given. And by using a Blink IoT app, I had connected my mobile to. So here we can remotely switch on the cooler, switch on the heater, and also inlet valve on. So whenever I switch on the cooler, so here the display shows that cooler is on, and also the temperature and the volume is shown. So whenever I off that, it also shows that cooler is in off state. And whenever the heater is on, it shows the temperature that is of 27 or 28 degrees centigrade. Whenever the temperature rises to 35, above 35, then the heater automatically offs. And also it shows that in the display. Coming to here, the display shows. Cooler is in on state. So we can vary that. We can remotely operate both the cooler and heater from our mobile app, that is the Blink IoT. Next, coming to the remote sensing tank, we do change the properties right here itself. Okay. So the tank is full, so the inlet will be off. So whenever the tank is on, so the water flows, right? Wait a minute. So we had on the inlet valve. So the water flows through the serial remote tank. So the volume will be 700, 800, 900. So when it reaches above 200, the inlet valve will be off state, will be in off state. So the volume at present it is about 1000. So it reached 2000. After reaching 2000, after some time, we can off the inlet valve. So inlet valve, whenever we off that, it means that the water flow stops. So the tank is full. And also it shows a volume of 3000. When the outlet valve is there, that means the water decreases gradually. That means we do use, right? So it decreases from 2000 to thousands and hundreds. So whenever outlet valve is off, then the water flow is continuous till it reaches 3000. That's it. Based on the inlet and outlet, we can easily see whether the tank is full or it's not filling, or it's full or not. It helps us very much. So it shows us about the tank is in full state or not. So here we can see that inlet valve is in off state. So on the display, it can be seen that the temperature is 27 and the volume is of 3000 liters, right? And the serial port we took here is COM2, and the tank is full here.
Here I will show you again.
Conclusion: using Blink IoT application and Pixin Lab simulator, simulated home automation where LED, temperature system, serial tank resemble light, heater, cooler, and water tank in real time. CLCD acts like a dashboard used for displaying the events. Widgets for Blink IoT app like button widgets are used to control heater, cooler, and inlet valve, outlet valve. Gauge widgets to display the temperature and the volume of the water. Thank you.